It's time to export the knowledge. Okay, so in this video we're going to be talking about the Hyperbola Locus, but this time we're going to learn how to move it around. So let's write down the general form. So x squared over a squared minus y squared over b squared equals 1, where b squared is equal to a squared lots of e squared minus 1. So if this is the general form, we're going to have to somehow alter it to get something that we can actually move. So the new form is x minus h squared over a squared minus y minus k squared over b squared. And b squared is still equal to a squared lots of e squared minus 1. What this does, it will make the hyperbola reposition itself so that the center will be at h comma k. So wherever h comma k is, that's where the center of the hyperbola is. That's the xy plane. If this was the center here, the asymptotes will have to go through the center, so we're going to have to reposition those. The directrices will also be changed, and the box that we made also has to move. So let's start with the asymptotes. We said previously that this is the form for the asymptotes. Now we're going to have to move it in some way, but how on earth are we going to do that? So it might not seem obvious at first, but we can actually do this. So what this does is that it will make sure that this linear line will go through h comma k, and it will do so at this gradient, this b over a gradient. We can also move this k to the other side, so y becomes the subject. Okay, now that we have the asymptotes moved, we need to move the directrices. So the directrices plus minus a over e. So now we're going to have to move it horizontally. So that's just plus our horizontal shift. With the box, when we did it with the origin and no position change, we went up b units, we went down b units, and we went across a units on both sides, and then we formed our box. So all we have to do is find out where h comma k is, let's say there, and then we just have to move the same distance away. And that'll be our box there. And from there we can draw our asymptotes, and we can get our vertex, and we can sketch our hyperbola. So let's do an example without the directrices, just focus on the asymptotes and the sketching part. So x minus 2 squared over 9 minus y plus 3 squared over 16 equals 1. So if we were to sketch this, we need to find our h comma k. So it's going to be the opposite of what's in the bracket here. So plus 2, so there's 2. And the opposite of what's in the brackets here, which is minus 3. Let's say about here. So if that is our point there, that's where we're going to have to center our graph. So zooming in, you can now go up 4 units, because that's our b value. So if that's 3, we're going to have to go to 1, so up here. and we're going to have to go down 4 units, so we're going to have to reach -7. We're also going to have to go across 3. We're going to reach to -1. And we're going to have to reach +5. Draw in our asymptotes. And now we need to write what our asymptotes are. So y is going to equal plus minus b over a. So b is 4, a is 3. And then we need to put our positioning like so. And that's our 2 asymptotes there. You can just think same value in the x brackets here, our opposite value for the y bracket here. Now we can get our vertex and we can sketch our hyperbola with great accuracy. Now, obviously you can do better on paper, but that shows you how to graph it as best as you can. So like all my other locus videos, you can go to the Desmos graph links below and you can actually have a play around with it. So you can adjust the slider here and see how it affects the graph. You can also change the positioning to whatever you like using the sliders here, or you can just grab the center right here and you can move it around to whatever you please. Additionally, you can go and take a look at all the work that went into making this actually possible, just generally, so you can use the sliders, and you can also turn off and on the square as much as you like. You can also just read off the E value for whatever you have set as an approximate value. So that's all I have for this video. If you have any questions, feel free to leave a comment down below or contact me on social media, and I will see you in the next video.